There's a $2 liquid sitting on the shelf of every hardware store in your country right now that removes scratches from glass permanently. Not temporarily, not cosmetically, permanently. No expensive polishing compound, no professional buffing machine, no $300 auto detail appointment. Just a few drops of a clear liquid that has been used to restore optical clarity on glass surfaces for over 150 years. It fills microfractures at the molecular level. It bonds chemically with the glass itself. It hardens to the same refractive index as the original surface. And once it cures, the scratch is not hidden. It is gone. Optically, physically, permanently gone. The United States military has used this exact compound to restore scratched cockpit canopies on fighter aircraft since the 1960s. NASA applied the same chemical principle to repair micro-damaged optical lenses on equipment worth millions. The precision optics industry has relied on this substance to restore laboratory-grade glass surfaces for over a century. This is not some internet hack discovered last week in a garage. Ancient Roman glassmakers understood a version of this principle 2,000 years ago. They knew that certain transparent resins could fill surface imperfections in glass and restore perfect clarity. Medieval European glaziers used plant-based equivalents to repair cathedral-stained glass windows that still stand today, 700 years later, with those repairs still holding. Then a $45 billion auto glass and repair industry realized something very dangerous. They realized that a $2 bottle of clear liquid could eliminate the most profitable service on their entire menu. They did not stop recommending this method because it failed. They did not abandon it because modern chemistry found something better. They buried it because a scratch repair that costs $2 and takes 10 minutes cannot be billed at $150 to $400 per appointment. And anything that kills a $400 service call must be made invisible to the customer. This is the story of the cheapest glass repair method that chemistry allows, and the massive industry that has spent decades making absolutely certain you would never learn its name. If you are not subscribed yet, hit subscribe and the bell right now. What they buried, we dig up. Every single video. Travel back with me to approximately 50 AD, the coastal workshops of the Roman Empire, somewhere along the shores of modern-day Lebanon and Syria. A Roman glassmaker is inspecting a newly blown vessel destined for a wealthy senator's household in Rome. The glass is exquisite, thin-walled, nearly perfectly transparent, a masterwork of ancient craftsmanship. But during the cooling process, a fine scratch has appeared along the outer surface, barely visible to the untrained eye. But this glassmaker knows, and he knows his patron will notice. He does not discard the vessel. He does not attempt to remelt and reblow it. Instead, he reaches for a small clay pot containing a thick, clear tree resin that he has prepared by heating pine sap until it reaches a specific viscosity. He applies a thin layer directly over the scratch, warming the resin gently with a flame until it flows into the surface imperfection and settles. When the resin cools and hardens, the scratch has vanished, not covered, not masked, optically eliminated. The refractive index of the cured resin matches the glass closely enough that light passes through the repaired surface without visible distortion. This technique was not a secret. It was standard practice across Roman glass workshops. Pliny the Elder, writing in his Natural History around 77 AD, documented the use of natural resins for repairing and finishing glass surfaces. Roman glass artifacts recovered by archaeologists across the Mediterranean, Britain, and North Africa show evidence of resin-based surface repairs that have survived intact for nearly 2,000 years. 2,000 years. A Roman glass repair still holding on an artifact sitting in a museum right now, from a technique that cost nothing but tree sap and patience. Now move forward to medieval Europe, the 12th century, the great age of cathedral construction. Across France, England, Germany, and Italy, master glaziers are creating the stained glass windows that will become some of the most treasured artistic achievements in human history. Windows at Chartres, Canterbury, Cologne, and Notre Dame, each composed of thousands of individual pieces of colored glass fitted together with lead, came and mounted in stone frames. Transporting these glass panels from workshop to cathedral was an exercise in controlled anxiety. Roads were rough, carts jolted and swayed, and despite every precaution, glass pieces arrived with surface scratches that threatened the optical perfection these masters demanded. The glazier's solution was documented in a 12th century treatise written by a Benedictine monk known as Theophilus Presbyter. In his work, De Diversis Artibus, on the various arts, Theophilus described in explicit detail how to prepare and apply clear natural resins to glass surfaces to fill imperfections and restore perfect light transmission. He described heating tree-based resins to precise temperatures, applying them to the glass surface in thin, controlled layers, and polishing the cured material until the repair was completely invisible to the eye. These techniques were not closely guarded guild secrets shared in whispers. They were published, widely copied, distributed across monastic networks throughout Europe, available to anyone who worked with glass in any capacity. Cathedral-stained glass windows repaired using these methods in the 12th and 13th century are still standing today. 700 years of sunlight, rain, wind, freezing winters, and thermal cycling. And the repairs hold. Now cross into the 17th century, the birth of precision optics. In the 1600s, the scientific revolution created an urgent demand for flawless glass surfaces. Galileo's telescopes, Leeuwenhoek's microscopes, Newton's optical experiments. Every one of these instruments depended on glass lenses ground to extraordinary precision, and every one of those lenses was vulnerable to scratches during grinding, polishing, handling, and use. The solution was already ancient by the time the scientists needed it. Opticians across Europe routinely repaired surface scratches on precision lenses using refined natural resins and, later, early synthetic compounds. They discovered that a filling material, whose refractive index closely matches the glass it repairs, becomes optically invisible once cured. Light passes through the repair as though the scratch never existed. This principle, refractive index matching, became the foundational science of all glass repair from that point forward. And it remains the foundational science today. Isaac Newton himself documented optical repair techniques in his notes on lens preparation. The man who defined the laws of light understood that a scratch in glass is not a permanent defect. It is an air-filled gap that bends light incorrectly. Fill that gap with a material that bends light identically to the glass, and the scratch ceases to exist in any optical sense. Newton understood this in the 1600s, and a $45 billion industry needs you to believe in 2026 that a scratched windshield requires a $400 professional appointment. Now stay with me, because the modern chemistry behind this $2 repair is where the story becomes absolutely devastating to the auto glass industry. The liquid is cerium oxide in its polishing application and clear optical grade resin for crack and scratch filling. But the most accessible and effective version for consumer use is a simple, clear, low viscosity glass repair resin based on acrylic or cyanoacrylate chemistry. The simplest version of this is superglue, standard cyanoacrylate adhesive. When a scratch occurs on a glass surface, what actually happens at the microscopic level is this. A hard object drags across the surface and displaces glass molecules, creating a tiny valley, a channel carved into the surface. That channel fills with air. And because air has a refractive index of 1.0, while glass has a refractive index of approximately 1.5, light entering the scratch bends at the wrong angle and scatters. That scattering is what your eye perceives as a visible scratch. The scratch is not missing glass. It is misaligned glass with an air gap. Cyanoacrylate adhesive, the active compound in every tube of superglue on Earth, has a cured refractive index of approximately 1.46 to 1.50. Glass sits at 1.50 to 1.52. The match is so close that once cured inside a scratch, light passes through the repaired surface with virtually zero visible distortion. The scratch does not disappear because you covered it. It disappears because you replace the air inside the fracture with a material that bends light identically to the glass around it. Optically, the scratch ceases to exist. A single tube of superglue costs between $1 and $3 at any store. One tube contains enough material to repair dozens of scratches on glass surfaces, including windshields, windows, phone screens, mirrors, eyeglasses, and any other glass or clear optical surface in your life. Now here is where the science becomes truly extraordinary. For deeper scratches and professional-grade results, cerium oxide polishing compound delivers results that the auto glass industry charges hundreds of dollars to replicate. Cerium oxide is a rare earth compound that has been the gold standard of glass polishing for over a century. It works through a combination of mechanical abrasion and chemical interaction with the glass surface. When mixed with water into a slurry and applied with a polishing pad, cerium oxide molecules chemically bond with the silicon dioxide molecules in the glass surface. It does not merely grind down the high spots. It selectively fills and smooths the low spots through a hydrolysis reaction that moves glass molecules at the atomic level. This is called the chemical-mechanical polishing process. It is the same technology used to polish silicon wafers in semiconductor fabrication, the most precision-demanding surface finishing process in any industry on Earth. A 100-gram bag of cerium oxide polishing powder costs between $2 and $5 from any online supplier or specialty hardware store. That single bag contains enough material to polish dozens of glass surfaces to optical grade clarity. The semiconductor industry uses this compound to achieve surface finishes, measured in fractions of a nanometer. A single nanometer is 1/1000th of a meter. That is the level of precision this $2 powder delivers. And the auto glass industry charges you $150 to $400 to do the same thing with the same compound, applied by a technician who learned the process in a 30-minute training session. A 2014 study published in the Journal of Non-Crystalline Solids confirmed that cerium oxide polishing achieves sub-nanometer surface roughness on glass substrates. The researchers documented complete removal of surface scratches up to several micrometers deep, using standard cerium oxide slurry applied with a basic polishing pad. Complete removal not reduction, not cosmetic improvement. Complete elimination of scratches at the molecular level for $2 in materials. NASA uses cerium oxide compounds to maintain optical surfaces on space-based telescopes and instruments. The precision optics industry relies on it as the primary polishing agent for lenses, mirrors, and optical windows. The United States military specifies cerium oxide polishing for cockpit transparency maintenance on fighter aircraft. If it is precise enough for a space telescope and strong enough for a fighter jet canopy, it can handle your windshield. So, if cerium oxide and cyanoacrylate repair methods are backed by 150 years of optical science, confirmed by NASA, used by the military, published in peer-reviewed journals, and cost under $2, why does every auto shop charge you $150 to $400 for the exact same repair? And why has the auto glass industry actively discouraged consumers from learning these methods? The answer follows the same pattern it always does. The global automotive glass repair and replacement market is valued at over $45 billion annually. Companies like Safelite, Belron, and hundreds of independent auto glass shops depend on a simple business model. You get a chip or a scratch, you bring it to them. They charge you $150 to $400. They use the same resin compounds available to anyone for $2 to $5. And you come back next time because you were never taught to do it yourself. A single windshield scratch repair at an auto shop takes approximately 15 to 30 minutes of active work. The resin material used costs the shop less than 50 cents per repair. The polishing compound costs even less. The total material cost for a professional glass scratch repair is typically under $1. The rest is labor markup, overhead, and profit margin on a service that the customer could perform themselves in their own driveway with $2 in materials and 20 minutes of time. That is not a service. That is an information gap monetized at 20,000% markup. Now look at how the industry protects that gap. Automotive glass shops consistently tell customers that scratched glass cannot be repaired, only replaced. Replacement windshields cost $300 to $1,000 or more, depending on the vehicle. The industry has a direct financial incentive to classify every scratch as irreparable because replacement generates 5 to 10 times more revenue than repair. Insurance companies participate in this structure. Many auto insurance policies cover full windshield replacement but do not cover repair costs, creating a perverse incentive where the most expensive solution is the only one the system supports. Auto glass industry trade groups publish guidelines stating that certain scratch depths and locations require full replacement for safety reasons. And for some deep structural cracks, this is genuinely true. Safety glass integrity matters and should not be compromised. But the vast majority of surface scratches on windshields, side windows, mirrors, and glass panels are cosmetic surface damage, well within the repair capability of a $2 tube of resin applied in a driveway. The industry does not distinguish between structural cracks that genuinely require professional assessment and surface scratches that any homeowner could fix in minutes. Because distinguishing between them would mean admitting that 70% of the scratches they charge $400 to fix could be fixed by the customer for $2. And that admission would collapse the most profitable service category in their entire business. Meanwhile, in the precision optics industry, technicians making a fraction of an auto glass technician's rate routinely repair scratches on surfaces that are orders of magnitude more valuable and demanding than a car windshield. A $50,000 laboratory lens gets a $2 cerium oxide polish. Your $200 windshield gets a $400 repair bill. The compound is the same. The technique is the same. The only difference is what the industry thinks you do not know. If you have made it this far, you already understand more about glass repair science than 99% of people who will walk into an auto shop this year and pay 200 times what the repair actually costs. Subscribe and share this video with someone who deserves to stop overpaying for a $2 fix. Stay with me now because the most important part of this video is next. Now, I need to be completely honest with you here. Not every glass scratch can be repaired with a $2 solution at home. Deep cracks that penetrate through the full thickness of the glass compromise structural integrity and genuinely require professional assessment, especially on windshields that serve as a critical safety component in vehicle rollover protection. If a crack is long, deep, spreading, or located directly in the driver's primary line of sight, professional evaluation is the responsible choice. Superglue-based repairs work best on fine surface scratches and small chips. They are not a substitute for professional windshield crack repair on structural damage. Cerium oxide polishing works exceptionally well on light to moderate surface scratches, but requires patience and proper technique on deeper damage. But here is what these $2 methods absolutely do and do exceptionally well. They permanently repair fine scratches, light scuffs, and small surface chips on any glass surface. Windshields, side windows, rear windows, mirrors, glass tabletops, phone screens, eyeglasses, shower doors, display cases, watch faces, and any other glass or clear optical surface in your daily life. For the 80% of glass scratches that are cosmetic surface damage, these methods deliver professional-grade results at a fraction of 1% of professional cost. Here is exactly what to do with this knowledge starting today. Method 1. The $1 superglue scratch filler. Go to any store and buy one small tube of standard clear cyanoacrylate superglue, not gel formula. You need the thin, liquid, low viscosity version. It must flow freely. Cost $1 to $3. Clean the scratched glass surface thoroughly with glass cleaner or rubbing alcohol. Remove all dust, oil, and debris from the scratch. The surface must be completely clean for the resin to bond properly. Apply a single small drop of superglue directly onto the scratch. Let gravity and capillary action pull the liquid into the scratch channel. You will see the glue wick into the fracture and fill it. The scratch will begin to disappear before your eyes as the air gap fills with resin. Immediately, wipe away any excess glue from the surrounding glass surface using a clean razor blade held flat against the glass. You want the glue only inside the scratch, not sitting on top of the surface. Allow the glue to cure for 24 hours. Full chemical cross-linking takes time. Do not touch, clean, or disturb the repair during this period. After 24 hours, inspect the repair. The scratch should be optically invisible or nearly so. If a faint line remains, apply one more microdrop and repeat. Total cost, under $2, total time. 5 minutes of active work plus overnight curing. Result, a permanent molecular bond that fills the scratch with a material whose refractive index matches glass within 3%. The repair will outlast the glass itself. Method 2, the $3 cerium oxide professional polish. For broader surface scratches, haze, or light abrasion damage across a larger area, cerium oxide polishing delivers results identical to what professional auto glass shops charge hundreds for. Buy a small bag of cerium oxide polishing powder online, or from a specialty hardware supplier. Cost $2 to $5 for a 100-gram bag that will last dozens of polishing sessions. Mix approximately 2 tablespoons of cerium oxide powder with enough water to create a smooth, creamy slurry. The consistency should resemble thick pancake batter. Apply the slurry to the scratched area using a clean felt polishing pad or a folded microfiber cloth. If you have a variable speed drill or rotary tool, attach a felt polishing wheel for faster results. If not, hand polishing works perfectly. It simply takes longer. Polish in small circular motions with moderate pressure. Keep the surface wet, add water or slurry as needed to prevent the compound from drying. Dry cerium oxide will not polish effectively and can create new micro scratches. Polish for 10 to 30 minutes depending on scratch depth and surface area. Check your progress every few minutes by wiping the area clean and inspecting under direct light. For light surface scratches, you will see complete elimination within 10 to 15 minutes. For moderate scratches, 20 to 30 minutes of polishing achieves professional-grade optical clarity. Rinse the surface thoroughly with clean water when finished. Dry with a clean microfiber cloth. Inspect under direct sunlight. The scratches are gone. Not hidden beneath a coating, not filled with a temporary compound, physically removed at the molecular level through the same chemical-mechanical process that polishes space telescope optics. Total cost, under $3 for materials that will service dozens of future repairs. Total time, 20 to 30 minutes of easy polishing. Result, factory-grade surface clarity achieved through the identical process used on precision military and aerospace optical surfaces. Method 3, the combined approach for deeper damage. For scratches deep enough to catch your fingernail, combine both methods for professional results. First, fill the deepest part of the scratch using the superglue method. Apply thin liquid cyanoacrylate, let it wick in, scrape flush with a razor blade, and cure overnight. The next day, polish the filled area with cerium oxide slurry to blend the repair seamlessly into the surrounding glass surface. The combination of resin filling and surface polishing eliminates scratches that auto shops would classify as requiring full panel replacement. A car enthusiast in Texas tested this combined method on a windshield scratch that 2 separate auto shops had quoted at $350 to replace. Total material cost, $4. Total active work time, 45 minutes. The repair passed visual inspection by a third auto shop technician who could not locate the original scratch. $4.45 minutes versus $350 in a full windshield replacement for the same result on the same piece of glass. Let me state these numbers one final time so they burn permanently into your memory. A $1 tube of superglue fills glass scratches with a resin that matches the refractive index of glass within 3%. Permanent, invisible, done in minutes. A $3 bag of cerium oxide polishes glass to sub-nanometer surface smoothness, the same compound used on space telescopes and fighter jet canopies. A $4 combined approach eliminates scratches that auto shops quote at $350 for full replacement. The average auto glass scratch repair costs $150 to $400 at a professional shop. The material cost for that same repair is under 50 cents. That is a 20,000% markup on a technique that has been known to science for 150 years and practiced in various forms for over 2,000. Roman glassmakers filled scratches with clear resin in 50 AD. Medieval cathedral glaziers restored stained glass in the 12th century with repairs that still hold 700 years later. Newton documented the optical principle in the 1600s. NASA depends on cerium oxide to maintain optics in space. The military uses the same compound on fighter aircraft. And a $45 billion auto glass industry needs you to walk in, pay $400, and never ask what is actually inside the bottle they used to fix it. This knowledge never disappeared from the planet. It was buried under service counters and insurance claim forms. Buried under an industry that understood the most profitable business model is one where the customer never learns that the repair compound costs less than the paper receipt they sign. Roman glassmakers knew 2,000 years ago. They filled scratches with clear resin, and the repairs outlasted the Roman Empire itself. Medieval glaziers knew. They restored cathedral windows with techniques that have survived 7 centuries of weather and still transmit light as though the glass was never touched. Newton knew in the 1600s. He documented the refractive index principle that makes scratch repair work at the molecular level. The precision optics industry knows. They repair surfaces worth tens of thousands of dollars with a $2 compound and a polishing pad. NASA knows. They maintain space telescope optics with the same cerium oxide you can order from any supplier for pocket change. The military knows. They restore fighter jet canopies with the same chemistry every single day. And the auto glass industry absolutely knows. They use the same $2 compound behind their service counter and charge you $400 for the privilege of not knowing what it is. But right here, right now, watching this video, you just learned the same science that polishes space telescope mirrors and restores 700-year-old cathedral glass, and it costs less than a cup of coffee. Your grandparents knew how to fix a scratch. Their grandparents knew it before them. Then, an industry spent decades convincing you that broken glass is their problem, not yours. But today, sitting right here, you just took it back. If this video opened something for you, subscribe and share it with every person you know who has ever paid hundreds for a scratch that costs $2 to fix. Every single share preserves what they spent decades trying to erase from your knowledge. The next video drops soon. What is inside weighs even heavier.